68's fun. It's because you start off with conservation of energy. As the block drops in height, it gains kinetic energy, and then you have a collision, and then you have a friction floor, and so you have more conservation energy, where uh, the kinetic energy in the block turns into thermal energy, work due to friction, heat energy. Alright, so we're given a height that this block starts at, h, and we know that this is mass 1 and mass 2. We know that mass 1 is mass 1 of those. That's kind of silly at first, but you'll see why later. We know that mass 2 is 2 times the mass of m1, so that's kind of why we did that. We know the height is 2.5 meters. Coefficient of friction here, mu k, because it's sliding, is 0.5, and it goes a distance d. So first we need conservation of energy to get the speed of the block 1 just before it hits, so that we can use conservation of momentum. So we got ug equals ke. m1gh equals 1/2 m1v1, let's call it v1 squared. m1's cancel, we're looking for v, so v1 is the square root of 2gh. Just a little bit of rearranging there. Plug in 2.5 and 9.8 and you get 7 meters per second. It's nice. So that's the speed of block 1 right before the collision. Now part A, it's an elastic collision, so we need conservation of momentum and kinetic energy. So let's do it. m1 v1 plus 0. I'm just going to do that right off because we know block 2 is at rest. No need to write multiple steps for that. m1 v1 final plus m2 v2 final. And we can plug in, well, we'll just call this m1, and this is 7, and that equals, because we got 7 from here, m1 v1 final plus, now m2 is 2 m1s, so we'll just substitute that in right now, v2 final, hey, bye bye, bye bye, bye bye. So we get 7 equals v1 final plus 2 v2 final. That's cool. But 2 unknowns, can't go any farther. We need kinetic energy. 1/2 m1 v1 squared plus 0, because it's at rest, equals 1/2 m1 v1 final squared plus 1/2 m2 v2 final squared. Halves go bye-bye. m1 times 7 squared, the initial velocity is 7, is 49, plus 0 equals m1 v1 final squared plus m2, remember, is 2 m1s, so we'll substitute that in right now, times v2 final squared. Hey, bye-bye, bye-bye, bye-bye. So you get 49 equals v1 final squared plus 2 v2 final squared. Now we can take this, let's solve this for v1f. v1f equals 7 minus 2 v2f. Take this v1f and stick it in here. Ew, got a foil. 49, 7 minus 2 v2f squared plus 2 v2f squared. 49 equals. I'll write the FOIL out. I'll just do it. So 7 squared is 49 minus 7 times 2 is 14. Double that is 28. V2F plus 2 squared is 4 V2F squared. And then don't forget this term, plus 2 V2F squared. Let's quadricize it. Oh, we don't need to. 4 nines cancel. Yay, that's nice. So we get 28 V2F equals 6 V2F squared. This V2F cancels as one of these. Divided by 6 on both sides. And you get V2F equals 4.7 meters per second. We done yet? Nope. Because this block starts off moving at 4.7, and by the time it hits the end of D, distance D, it stops. So there's conservation energy, because the kinetic energy with the speed turns into thermal energy. So KE equals thermal energy 1/2 m2 v2 final squared turns into force of friction times distance. Force of friction is mu k times the normal force, which is just mg, so m2 times g times the distance. M2's cancel, stick 4.7 in here, square it, 9.8. Mu k is 0.5. I'm just going to solve for d real quick. I don't want to plug those numbers in, because you can do that right now while you pause the video. So we get d is 2.2 meters. So that's part A. Let's do part B over here. And the only difference is it's an elastic collision, so we don't have to deal with this whole kinetic energy stuff because it doesn't apply. Same initial velocity of 7. I'm just going to rewrite it here. And this equation just changes slightly. We got m1 v initial plus 0 equals, they stick together, so m1 plus m2 quantity times v12 final. This is m1 times 7 equals, and don't forget m2 is 2 m1s, so this is 2 m1s plus 1, so that's 3 m1s times v12f. These cancel. Solve for v12f, and you get 2.3 meters per second. Should make sense, because two masses are harder to push than one, so the speed shouldn't be as high as it is when just 2 is by itself, and it's not. Now, conservation energy again. Kinetic energy turns into thermal energy. Now it's both masses, so we got 1/2 times m12 v12 final squared equals mu k times m12 times g times d. This is the normal force, m12g. m12's cancel. v12f is 2.3, g is 9.8, coefficient of friction is 0.5. Solve, you get d equals 0.56 meters. As expected, it doesn't go as far because there's more mass and when they're combined, and just doesn't have, it has the same amount of energy to begin with because it's dropped from the same height. So because of that, that energy has to be distributed between the two masses, and it can't send it as far. Bye bye.